Just beyond the edge of the Japanese mainland, where the Pacific Ocean stretches into a seemingly endless blue, something strange is happening deep beneath the waves. It's not the kind of spectacle that would catch the eye of a casual observer. There are no towering plumes of steam, no surging tides, no cracks in the Earth's crust spewing molten rock into the sea. In fact, if you were to fly over the area, or even sail right across it, you might notice nothing at all. The ocean, as always, appears calm, serene, even. But far below the surface, in the dark, crushing stillness of the seafloor, a slow, relentless process is unfolding. Something is rising. Something enormous. And it hasn't shown any signs of stopping. This isn't a headline-grabbing eruption or a sudden earthquake that rattles cities and topples buildings. It's subtler, almost eerily quiet. But for the scientists tracking it, the changes are impossible to ignore. Underwater terrain that was once mapped and measured to be stable and predictable has begun to shift, lifting upward in ways that defy casual explanation. The movement is not chaotic, not violent. It is measured, steady, and persistent, like the rhythmic breathing of some vast, sleeping creature. Entire sections of the seafloor are lifting, inch by inch, month after month, distorting the landscape in slow motion. And with each passing survey, the scale of this hidden transformation grows harder to overlook. To appreciate the enormity of what's happening, you first have to understand the location. Roughly 1,000 kilometers south of Tokyo, nestled deep within the western Pacific, lies a small but incredibly active volcanic island called Nishinoshima. It may not be a household name, but to volcanologists and marine geologists, it's a site of great interest and growing concern. The island itself is the visible tip of a much larger underwater volcanic structure, one that sits at the convergence of powerful tectonic forces. The Pacific Plate, one of the largest slabs of Earth's crust, is sliding beneath the Philippine Sea Plate in a slow, grinding motion that creates intense geological activity. This region, known as the Isobonin-Mariana Arc, is a volcanic hotspot, home to some of the most active and volatile underwater volcanoes on Earth. Nishinoshima first made headlines in the 1970s when it erupted from the sea in a dramatic display, forming new land above the waves for the first time in recorded history. Then, in 2013, it erupted again, growing rapidly as lava poured out and hardened into fresh coastline, eventually merging with an older volcanic island nearby. What was once a lonely speck in the ocean quickly became a dramatically larger landmass, a kind of geological time-lapse playing out in real life. But these surface-level events, while dramatic, may pale in comparison to what has been occurring in the deep. What the world couldn't see, was the vast, creeping transformation unfolding far below. Using sonar imaging, satellite altimetry, and deep-sea surveys, Japanese research vessels began to notice something unusual beneath and around Nishinoshima. Sections of the ocean floor weren't remaining static. They were shifting upward. And not just by a few centimeters. In some regions, the uplift measured several meters in a shockingly short span of time. Imagine an area of ocean the size of a small city slowly lifting itself upward, an invisible landform inflating beneath the sea. To the untrained eye, this might not seem like a big deal. But to those who map and study the seafloor for a living, these kinds of vertical shifts are anything but ordinary. They're rare, they're difficult to explain, and they almost always indicate that something significant is occurring beneath the crust. Usually, any form of volcanic activity this large would be accompanied by other signs: earthquakes, gas emissions, increased water temperatures, shifts in marine ecosystems. But in this case, the change has been oddly quiet. No earthquakes strong enough to match the movement. No drastic changes in sea temperature. No surface boiling, churning, or discoloration. The seafloor is simply rising. On its own terms. In its own time. When marine geologists aboard the Japanese research ship Keiomaru No. 5 returned from their expedition near Nishinoshima, they brought back more than just data. They carried the first indications that something strange was unfolding. High-resolution bathymetric maps revealed the changing topography in exquisite detail. Seafloor ridges that hadn't existed before now arched upward like slow waves frozen in stone. The very texture of the terrain had changed, subtly but undeniably. And even more curiously, the rate of uplift wasn't slowing down. If anything, it seemed to be continuing at a near constant pace. It was as if something deep beneath the earth was pressing upward with deliberate, unstoppable force. In the world of volcanology, slow processes can often be more unsettling than rapid ones. Explosions, after all, are over quickly. But this kind of persistent, creeping rise suggests a source of pressure that is vast, continuous, and perhaps growing. Like a pot slowly heating on a stove, the seafloor near Nishinoshima is transforming under the surface tension of something hidden, something building. And it's not just a few isolated points. The uplift is spread across a broad region, affecting not just the immediate volcanic cone but the surrounding area as well. Entire sections of the ocean bottom are bowing upward in a gradual arc, distorting maps and challenging assumptions. It is, in every sense, a mystery, one that is slowly but surely rewriting the landscape beneath the waves. As days turn to months and months into years, what started as a curious anomaly has become a subject of growing focus among researchers. International teams have started to monitor the region more closely, deploying remote-operated vehicles, installing pressure sensors on the seafloor, and analyzing satellite data for any irregularities. Still, the phenomenon continues. Steady. Unyielding. Unexplained. Something massive is growing underwater near Japan. And it's not stopping. Before we continue, we would like to remind you to consider subscribing and liking the video to support us in this journey. For those tracking this phenomenon, the sheer scale of the uplift beneath the sea has sparked a wave of speculation. But among the many possibilities scientists have begun to quietly explore, one stands out, not because it's the most dramatic, but because it's the most grounded in geological behavior. It's a theory rooted in known science, yet made all the more eerie by the size and silence of what's taking place. Some researchers believe what we may be witnessing is the slow birth, or perhaps reawakening, of a massive underwater volcano. At first, that might not sound too surprising. After all, the Pacific region surrounding Japan is part of the infamous Ring of Fire, a massive horseshoe-shaped zone packed with hundreds of volcanoes, both active and dormant. Eruptions aren't unusual here. But what makes this situation different, and far more intriguing, is the way in which the suspected volcano appears to be forming. Rather than announcing itself with the fiery violence most people associate with eruptions, this one seems to be growing like something alive, quietly, methodically, and with remarkable consistency. There's no smoke, no flame, no sudden explosion, just a constant, steady buildup of pressure and terrain beneath the surface. Think of it like this: volcanoes don't just appear out of nowhere. They're built over time, layer by layer, as magma, molten rock from deep within the earth, pushes upward and finds its way toward the crust. In most cases, when the pressure becomes too great, the magma bursts forth, creating dramatic eruptions that send ash and lava into the sky. But if the magma rises slowly, and has no immediate escape route, it can begin to accumulate beneath the surface instead, forming large bulges in the Earth's crust. On land, we call these domes. Underwater, they're harder to detect, hidden beneath kilometers of ocean and sediment. But they follow the same process. Slowly, over months or even years, the seafloor can begin to swell as magma pools just beneath it, lifting everything above it inch by inch. That's exactly what appears to be happening near Nishinoshima. What makes this process so fascinating, and so unnerving, is its silence. Normally, rising magma triggers seismic activity as it forces its way upward, fracturing rock and shifting layers of the crust. But here, the uplift seems to be happening with little to no accompanying earthquakes. That's unusual. It's like watching a balloon inflate in slow motion, without ever hearing the hiss of air being pumped in. The seafloor is lifting, but the earth around it is whisper quiet. That's either a sign of a very gradual and stable buildup of magma, or it could mean that the pressure is being contained in a way we don't fully understand yet. To put the scale in perspective, consider this: satellite altimetry and sonar mapping have shown sections of the seafloor rising by several meters in just a few years. For something as immense and dense as oceanic crust to shift like that, there has to be an incredible force beneath it. Imagine the weight of all that rock, sediment, and ocean pressing down, and still, something underneath is pushing back. It's like watching the lid of a pressure cooker slowly bulge, knowing full well that something hot is brewing inside. Except in this case, we can't see the cooker. We can only see the results. Some volcanologists have compared this situation to the early stages of other seamount formations, those towering underwater mountains that begin life as magma accumulations and over time, either erupt dramatically or remain as quiet giants on the ocean floor. What's different here is how rapidly the change is occurring, and how close it is to populated regions. If this is the early formation of a new volcanic structure, it may be one of the largest and most active ones we've witnessed in recent history. And what makes it even more intriguing is that it's growing in secret, deep beneath the ocean's surface, hidden from view, but leaving behind clear and measurable fingerprints in the shape of a rising seafloor. It's a scenario that has scientists watching closely, not with panic, but with deep curiosity and a touch of concern. Because while underwater volcanoes can form without ever breaking the surface, sometimes they don't stay quiet forever. Sometimes the pressure builds until something gives. And if that happens, the consequences can be more than just geological, they can be global. But for now, the only thing we know for sure is this: something massive is growing. And the most logical explanation is that magma, ancient and unstoppable, is slowly shaping a new giant beneath the waves. If this really is the slow, silent birth of a volcano deep beneath the sea, then we're not just witnessing a geological event, we're watching a process that could span decades, even centuries, unfolding in real time. And while the initial signs might be subtle, mere ripples in sonar data or faint bulges in seafloor maps, the story they tell is anything but ordinary. One of the most overlooked aspects of submarine volcanoes is just how complex and layered their development can be. On land, it's easy to track the growth of a volcanic cone. We can see the ash layers, the lava flows, the new terrain forming in real time. Underwater, it's a completely different game. Every stage of development is masked by the dense ocean around it. And yet, the dynamics happening below are just as intricate. Magma rising from deep in the mantle doesn't just move upward in a straight shot. It meanders, seeps into cracks, melts pockets of older rock, and sometimes even forms chambers that remain dormant for years before anything happens at all. These magma chambers act like reservoirs, building up heat and pressure until they either breach the crust or stabilize. The current uplift may be the quiet prelude to one of these hidden magma systems maturing beneath Japan's oceanic shelf. Another thing to keep in mind is that underwater volcanoes don't always look like the dramatic conical peaks we imagine. In fact, many of them grow outward as much as they do upward. They begin as wide, dome-shaped bulges, sometimes hundreds of meters across, slowly layering volcanic material across the seafloor. These layers build from eruptions too weak to breach the ocean surface, but strong enough to release lava that spreads like syrup across the seabed, cooling almost instantly when it meets cold seawater. Over time, those flat, hardened layers stack on top of each other, forming massive platforms of volcanic rock that extend like sprawling plateaus beneath the sea. And these structures are anything but uniform. As the magma continues to pool and shift beneath the surface, it causes strange distortions in the landscape: folds, ridges, fractures. You might see an area that once sloped gently suddenly rise into a steep shelf, or a smooth plain turn into a jagged field of volcanic glass and boulders. These aren't the kinds of changes visible to the naked eye, but deep-sea ROVs and sonar imaging have revealed these telltale signs time and again near active submarine volcanoes. The area near Nishinoshima has shown similar anomalies, suggesting that the seafloor there isn't just rising, it's reshaping itself into something entirely new. What's even more fascinating is how the environment responds. As this volcanic feature grows, the water chemistry around it begins to shift in subtle ways. Microscopic sensors detect faint increases in temperature, dissolved minerals, and gas concentrations, clues that magma might be getting closer to the surface, even if it hasn't erupted. These chemical fingerprints are like breadcrumbs, telling scientists exactly how active the hidden volcano might be. Near Nishinoshima, those sensors have picked up traces of hydrothermal venting, tiny jets of superheated water and gas that escape from the crust when magma gets near, but not close enough to explode. These venting sites can appear suddenly and vanish just as quickly, but when they show up in a region where the seafloor is also rising, that's a pattern volcanologists don't take lightly. What's equally interesting, and perhaps a little eerie, is how quiet the surrounding area remains despite all this. Marine life, typically sensitive to environmental change, seems to be gradually relocating. Sonar data has shown shifting fish populations, almost as if the deep ocean creatures can sense something long before we can measure it. It's a subtle sign, but one worth noting. In past events involving submarine volcanic activity, similar patterns have emerged, fish migrating away from an area in the months or even years before a major geological shift. Whether it's due to temperature changes, acoustic cues, or something more instinctual, no one can say for sure. But it's another thread in the larger tapestry being woven beneath the surface. And let's not forget the scale of this structure. The area in question isn't just a small bump in the ocean floor. We're talking about an uplift zone that spans kilometers, possibly more, slowly rising like the back of some ancient creature stirring in its sleep. The more we map it, the more we realize just how immense the formation already is. And while it may take years to breach the surface, if it ever does, its very existence is reshaping the oceanic terrain in ways we're only beginning to understand. In many ways, this potential volcano is like a puzzle that hasn't finished assembling itself. We see the edges forming, a few key pieces snapping into place, but the full picture is still obscured. And yet, the signs are unmistakable. Something is growing, something powerful, and it's doing so in the deep, dark silence of the Pacific, just beyond the limits of human sight. But what if this isn't volcanic at all? Let's say for a moment that magma has nothing to do with it. Let's suppose that the steady, almost hypnotic rise of the seafloor near Japan isn't being caused by molten rocks slowly pushing its way up from deep within the earth. Instead, imagine that what we're seeing is the surface effect of something far deeper, far more structural, something driven not by heat, but by pressure. The shifting of tectonic plates. This brings us to the possibility of tectonic uplift, a phenomenon that, while not as explosive as volcanic eruptions, has the power to rearrange entire coastlines over time. It's quiet. It's patient. But it never stops. And in the context of what's happening near Japan, it might be one of the most plausible, yet underappreciated, culprits in the story. To understand this, we have to zoom out and look at the bigger picture, the massive, invisible conveyor belt of the Earth's crust that is constantly in motion beneath us. Japan, as it happens, sits on the edge of one of the most seismically complex regions on Earth. It's the meeting point of several major tectonic plates, including the Pacific Plate, the Philippine Sea Plate, and the Okhotsk Plate. These titanic slabs of rock are constantly pushing, pulling, grinding, and diving under one another in a process called subduction. Over thousands, or even millions, of years, this movement builds mountains, forms ocean trenches, and sometimes creates the very conditions needed for earthquakes or volcanic eruptions. But subduction doesn't always express itself through sudden, violent motion. Sometimes the result is far more subtle, an entire region of crust being forced upward, slowly and steadily, like a massive stone table being jacked up from underneath. And when that happens under the ocean, it's called seafloor uplift, a gentle rise of the seabed that can go unnoticed for years until someone takes a closer look. What makes this scenario so compelling in the case of the mysterious bulge near Japan is the sheer location of the event. The uplift has been detected along the Isobonin-Mariana Arc, a geologically active stretch that runs through one of the most tectonically stressed corridors on the planet. Here, the Pacific Plate is relentlessly plunging beneath the Philippine Sea Plate, sliding down into the Earth's mantle at a sharp angle. This process creates enormous amounts of friction, heat, and stress within the crust. Sometimes the energy is released as earthquakes. Other times, that stress simply causes one section of crust to buckle upward. And the thing is, this uplift doesn't have to be dramatic to be significant. Even just a few centimeters per year, spread over a wide area, can result in massive elevation gains over time. Scientists studying similar events in the past have seen coastal areas rise by several meters over just a few decades, enough to leave previously submerged coral reefs high and dry, or to push entire island chains further above sea level. Underwater, these changes are harder to detect at first glance, but modern sonar mapping and satellite-based altimetry have started to pull back the curtain. What we're seeing near Japan could be the early stages of just such a tectonic reshaping. There's also the matter of stress accumulation. As plates grind past each other, energy gets stored within the rocks themselves. It's not unlike pulling back the string of a bow. The more you pull, the more tension builds, until eventually, something gives. In the case of tectonic uplift, the pressure might be distributed unevenly, causing bulging in localized areas. These bulges can resemble volcanic activity in their shape and scale but have no molten core. Instead, they're just the crust physically warping due to immense pressure, like a sheet of metal being slowly bent from below. And just like a bowstring, this uplifted crust doesn't always stay where it is. If the stress becomes too great, it could snap back in a sudden jolt, causing an earthquake, or worse, an undersea landslide. But in the meantime, all we see is the steady, unnerving rise of the seabed. No smoke. No lava. Just a silent push, day after day, year after year. What makes tectonic uplift particularly fascinating is how invisible it is in daily life. If you lived on land near such a zone, you might never notice anything unusual. Your coastline might gradually change. Tidal patterns might subtly shift. But beneath the ocean, these changes are happening in near-perfect isolation. No human eyes see it. No camera captures it. Only a network of remote sensors, deep ocean probes, and satellite instruments quietly record the slow heave of the Earth. So when researchers began comparing seafloor elevation data from previous years to more recent scans, and noticed entire sections rising by meters, sometimes even 10 meters or more, it didn't look like a single explosive event. It looked like structural motion. Something fundamental. A grinding, glacial shift of Earth's skin. And that might be what's so eerie about it. Because tectonic uplift isn't something you can stop. There's no pressure release valve. No safety switch. The plates will keep moving whether we like it or not, and the forces they unleash are on a scale that makes human efforts seem microscopic. This isn't just a local anomaly, it could be the surface ripple of something far bigger, stretching across fault lines and plate boundaries that are always in motion. If we zoom in even closer to the mechanics of tectonic uplift, we begin to understand that what's happening beneath the seafloor isn't just a single push upward, it's a complex ballet of stress redistribution and crustal warping that plays out across a dynamic, interconnected system. Picture the Earth's crust not as a rigid, flat surface, but more like a patchwork of floating platforms, immense slabs of rock jostling for position over a churning sea of molten mantle. These platforms, tectonic plates, aren't moving smoothly. They're grinding, they're colliding, they're slipping. And as one plate dives under another, the upper plate doesn't always accept that pressure evenly. Sometimes, portions of that upper plate begin to flex, almost like a bow being bent, but across an area that spans hundreds of square kilometers. It's in this flexing where we find the heartbeat of tectonic uplift. That rising patch of seafloor near Japan? It might just be the apex of one of these massive geologic bows, one that's slowly arching upward, pulled by forces deep beneath the surface that have been gathering for decades. And the most intriguing part? This kind of deformation doesn't happen in isolation. Even small variations in one region of a tectonic plate can ripple outward like shockwaves in a pond, subtly influencing the behavior of faults, volcanoes, and seismic zones in areas hundreds of miles away. It's like watching a great steel bridge shift imperceptibly in the wind. You know it's designed to flex, but the moment you notice movement, you start to wonder just how much tension it's really holding. Now, underwater, this flexing introduces a whole new set of variables. Unlike surface uplift on land, which can be measured using GPS and laser scanning tools, submarine uplift occurs in near total darkness, muffled by the immense weight of the ocean above. That means the initial stages of tectonic uplift might go entirely unnoticed, until marine geologists review bathymetric data and realize that something has shifted. When they do, what they often find is startling: wide, gradual domes forming on the ocean floor where before it was flat. These aren't dramatic cliffs or jagged ridges, just smooth, slow, persistent swelling. And let's not forget the role of hydration and sediment load in these regions. Many parts of the ocean floor near subduction zones are covered in deep layers of sediment, some of which are saturated with water. As tectonic plates converge and compress these wet layers, the water trapped within them starts to play a surprising role. It acts almost like a lubricant in some zones, reducing friction and allowing the crust above to bend more easily. In others, it builds up pressure, adding another dimension to the already complex geological activity. Some researchers believe that these pressurized sediments can accelerate uplift in localized pockets, essentially creating mini uplift zones that grow independently of the main plate movement. This makes the whole situation even more unpredictable. You're no longer dealing with a single, slow push. You're looking at an entire geological system behaving like a series of pulsing, shifting pressure zones, each with the potential to cause structural changes that span not just miles, but potentially regions. And in the case of the uplift near Japan, this could mean we're not witnessing a singular event, but a much larger shift that's just beginning to make itself visible. One of the more fascinating aspects of tectonic uplift, especially in subduction zones, is how it can mask or delay more dangerous events. Sometimes, uplift precedes a major earthquake, not because the crust is relaxing, but because it's under such immense stress that it's warping upwards before it finally breaks. Other times, the uplift is a warning sign that pressure is migrating, quietly loading tension into neighboring fault systems that aren't yet on anyone's radar. It's a geological sleight of hand. While all eyes are focused on one rising region, the real danger may be assembling somewhere else entirely. And that's why this rising dome near Japan is turning heads. Not because it's erupting or shaking violently, but because it's not. It's moving silently, steadily, in a part of the world that's geologically restless, yet oddly quiet in this very specific location. Almost too quiet. The question isn't just why it's rising, but what else might be adjusting in response. We might be watching the surface of the seafloor like it's a stage, unaware that the real show is happening behind the curtain. Of course, while tectonic uplift remains a leading contender, it doesn't explain everything. The rate of inflation, the shape of the rise, the eerie quiet in the surrounding geological systems, it all leaves a trail of unanswered questions. And it's those questions, those quiet little inconsistencies, that open the door to more unconventional ideas. The kind of theories that start as murmurs in scientific circles and gradually gain traction, not because they're proven, but because they explain what traditional models can't. So here's one of them. What if we're not looking at tectonic activity at all? What if the swelling seafloor isn't being pushed from below by magma or shifting plates, but rather by something growing? Not a volcano. Not a dome of pressurized rock. But a massive, slow-expanding geobiological structure. Something alive, or once alive, emerging from deep within the Earth's crust. Now, before you roll your eyes, consider this. Earth's subsurface is one of the least explored regions of our planet. We've mapped more of the surface of Mars than we have the deep seafloor. Beneath the sediment, beneath the volcanic ridges and tectonic lines, there's a mysterious biosphere, a dark, pressurized realm that hosts microorganisms that thrive in conditions no surface life could survive. Scientists call it the deep biosphere, and we've only just begun to understand what actually lives down there. But what if there's more than just microbes? Some researchers have speculated for years about the existence of massive subterranean colonies of extremophiles, organisms that feed off geothermal energy, some of which may form symbiotic superstructures. They wouldn't look like anything we'd recognize. No skeletons, no shells, just dense, slow-growing matrices of organic material adapted to the crushing pressure and pitch-black silence of the deep. We're not talking about mythical sea monsters or giant squids here. Think bigger. Think alien coral reefs, biological masses that pulse and grow with geothermal heat as their engine, expanding inch by inch over decades. Now imagine that one of these massive structures has reached a point where it's pressing against the ocean floor above. It doesn't erupt. It doesn't explode. It simply grows, pushing upward in complete silence, displacing sediment and rock without making a sound. It might release no gases. It might cause no quakes. It wouldn't behave like a volcano or a fault line. It would rise like a phantom. And the implications of such a phenomenon are staggering. First off, we'd have no way to detect it until it was already influencing the shape of the seafloor. Standard seismic tools wouldn't pick it up. Sonar mapping might show the dome, sure, but the interior? It would be a black box. Even deep-sea drilling might miss it, boring into the surface without ever realizing that what lies beneath isn't rock, but something else. Something living. Or formerly living. What's more, this theory might even help explain some of the oddities that researchers have quietly flagged over the years. Patches of ocean that inexplicably grow warmer without hydrothermal vents. Minor fluctuations in electromagnetic fields above rising domes. Areas where marine life avoids without any obvious reason. It all starts to look different when you allow for the possibility that the Earth might not just be geologically active, but biologically active in ways we've never imagined. And here's where it gets even stranger. Some geobiologists have floated the hypothesis that certain forms of deep life could survive for eons, metabolizing slowly enough to span geological ages. What if this structure under the sea near Japan has been growing for thousands of years unnoticed? What if it's only now breaching a threshold, breaking through sediment layers that have hidden it from views since the last ice age? It could explain the perfectly smooth, dome-like shape we're seeing. It's not a pressure bulge. It's the tip of something vast. And yet, even as we entertain this theory, it remains shrouded in speculation. There's no consensus. No confirming data. But sometimes, the absence of obvious answers is itself the most compelling clue. When everything normal fails to fit, the abnormal starts to look more plausible. And in a world where life has adapted to thrive in boiling acid pools and frozen methane lakes, is it really so far-fetched to think it might also have carved out an empire far below our feet? So as scientists continue to watch the mysterious dome grow near Japan, a quiet question lingers in the background, unspoken, maybe even unthinkable. What if the Earth isn't just shifting? What if it's awakening? Let's suspend disbelief for a moment longer, not to escape reality, but to stretch it. To imagine, with just enough scientific grounding, what it might mean if something vast, ancient, and alive has been slowly growing in the darkest corners of our world. Because the thing is, the ocean floor isn't some flat, lifeless expanse. It's riddled with hidden ecosystems, uncharted ridges, hydrothermal fields, and abyssal plains that no human eye has ever seen in person. We talk about space like it's the final frontier, but right now, beneath us, there are landscapes no one has ever stepped foot on, and creatures no one has ever studied. In this silent realm, something could grow unnoticed for decades, even centuries, without making a single ripple on the surface. Until now. This structure near Japan, this mysterious dome pushing upward, is a perfect example. From above, it may just look like a smooth bump in the ocean floor, an anomaly in bathymetric readings. But what if the reason it's rising isn't pressure from molten rock, but the slow, methodical expansion of something organic? Something that feeds on geothermal energy, that absorbs minerals from its environment, that grows not with sunlight, but with heat and time? We wouldn't even recognize it at first. To us, it might resemble stone. But under the microscope, or under the surface, it could be as different from rock as bone is from granite. Consider how coral reefs form. Minute organisms, working collectively, build sprawling marine superstructures that support entire ecosystems. Yet coral thrives in sunlight, in shallow waters. Now reverse that idea. Think of a reef built by extremophiles, life forms that don't need light or oxygen, that flourish in scalding temperatures and crushing pressures. These organisms might not form colorful gardens, but dense, porous masses, biological fortresses sculpted by time and chemistry. Over thousands of years, one could become the size of a mountain. What we're seeing off the coast of Japan could be the exposed tip of one of these enigmatic giants, slowly surfacing through layers of sediment. And maybe it's not just size that matters, it's purpose. Some scientists have entertained the idea that deep Earth life might evolve structures for navigation, communication, or even defense. Not intelligent, in the way we think of intelligence, but responsive. Adaptive. A kind of intelligence written in patterns, like the branching of fungi or the behavior of slime molds. What if this massive form isn't just growing aimlessly, but responding to changes in the environment above? Perhaps the warming of the oceans, the shifting of the tectonic plates, or the introduction of new chemical signatures from pollution or drilling has acted like a signal, one that triggers a growth phase, or a migration, or even an emergence. And if it's rising with intent, if it's reaching for something, what happens when it gets there? That's the part no one can answer. Imagine marine research vessels sending down unmanned submersibles, only to find that the seafloor isn't what they expected. Instead of lava tubes or fault lines, they find soft, spongy material with strange, fibrous textures. The equipment begins to pick up faint pulses, electrical rhythms not unlike the ones some jellyfish produce. Sonar pings bounce off in unpredictable ways, suggesting the structure is neither fully solid nor entirely hollow, but something in between. Samples brought to the surface refuse to stay inert, reacting subtly to temperature or pressure changes. The data doesn't match any known biological structure. That's when speculation becomes obsession. And it's not hard to imagine how this could trigger a flurry of clandestine interest. Government agencies, defense departments, biotech companies, what if they see not just mystery, but opportunity? A living mass, untouched by sunlight, ancient beyond comprehension, possibly containing compounds or bioprocesses never seen before. The potential for new medicines, new materials, even new energy sources. And at the same time, a potential threat. Because if it's growing, that means it's changing. And anything that can change on a planetary scale, quietly, invisibly, is something that demands attention. So we return to the dome, not just a bump in the ocean floor, but perhaps a biological signal flare. A sign that something deep within Earth is awakening, stretching, pushing upward into our world. Not violently, not explosively, but insistently. And for now, all we can do is watch, wonder, and wait. Because sometimes, the quietest phenomena are the ones that end up changing everything. Now, let's take a step back and look at just what this could mean for us. To start, let's look at the immediate effect this growth could have on our planet's ecosystems, especially those we depend on most. The ocean is the lifeblood of Earth, covering more than 70% of its surface and regulating everything from weather patterns to oxygen production. If something massive starts to rise from the depths, slowly pushing the ocean floor upwards, it's not just displacing rocks and minerals, it's disrupting the entire aquatic ecosystem. Imagine a slow but undeniable change in ocean currents, shifting the way nutrients are distributed across vast areas of the sea. Areas that were once rich with marine life could start to suffer. Fishermen who rely on these waters could see their catches dwindle as ecosystems struggle to adapt to the new, altered seafloor. The delicate balance that has existed for millions of years could be on the edge of tipping. But it's not just the fishers and the marine life that would feel this shift, it's us too. Think of the food we eat, the seafood that forms a cornerstone of many cultures' diets. From sushi in Japan to shellfish harvests along the coasts of the US, the world's reliance on the ocean for food is staggering. If this mysterious formation deep in the Pacific is truly altering marine life in ways we don't yet understand, it could lead to a ripple effect on global food security. And it wouldn't stop there. Scientists are still studying the impact of oceanic changes on global weather patterns, particularly in the context of ocean circulation and the distribution of heat. An even subtle change could have lasting effects on the climate, making storms more unpredictable, changing rainfall patterns, and even shifting weather extremes in ways we're not prepared for. But let's move beyond the immediate environmental impact and start thinking long-term. What if, over the course of decades, this phenomenon begins to interact more aggressively with the atmosphere? Rising volcanic activity, whether from this formation or others nearby, could mean increased amounts of greenhouse gases like carbon dioxide and sulfur dioxide entering the air. While the oceans naturally absorb a significant amount of CO2, an unprecedented geological shift could accelerate the breakdown of those natural processes. If this underwater growth is part of something much bigger, something linked to a supervolcano or a massive shifting of the Earth's crust, the greenhouse effect could intensify, causing global temperatures to rise at an alarming rate. In turn, this would have far-reaching effects on agriculture, infrastructure, and ultimately, the global economy. Now, let's explore the human impact, starting with how this could change geopolitics. The waters around Japan are far from a quiet backwater, they're highly contested. Multiple countries rely on these seas for shipping lanes, resources, and energy production. If this formation is indeed part of an ever-expanding volcanic system, the area could become a hotspot for international tension. Imagine, for a moment, if Japan or other nations with territory in the region began to assert control over this underwater growth. New territory, even in the form of submerged land, could become a resource goldmine, whether for fisheries, mineral extraction, or even geothermal energy. It's not hard to see how countries might begin jockeying for influence over this area, potentially triggering disputes, resource grabs, and even conflict. But let's take this one step further. What if, as we've speculated, this growth is more than just a biological or geological anomaly? What if it's the first sign of a larger, global change, something that humans are ill-equipped to handle in terms of both technology and philosophy? The mere existence of something rising from the ocean floor, something unprecedented and mysterious, might challenge the way we think about Earth, life, and our place in it. Scientists, environmentalists, and even theologians might begin debating the significance of this growth. Is it a harbinger of doom, a warning from the Earth itself? Or is it simply a random, natural event that we'll adapt to in time? No matter which side of the debate you fall on, the fact that this could trigger a philosophical shift in human thinking is undeniable. And as we look at the longer-term consequences of this growing phenomenon, we have to ask ourselves, how prepared are we for something like this? Historically, humanity has often been caught off guard by natural disasters, earthquakes, tsunamis, volcanic eruptions, that we didn't see coming, or we underestimated the scale of. But this is different. This is something slowly, almost imperceptibly, building. It's not a massive eruption tomorrow, but a creeping expansion that could eventually reach a critical point. And the thing about slow burn threats is that they often catch us when we're least prepared, precisely because they don't demand immediate action. That means the global response, if this is truly something world-changing, could be far behind the curve. The question then is whether we, collectively, as a species, are prepared to face the unknown. This phenomenon, growing quietly beneath the waves, could be our wake-up call. Not just to the fragility of our ecosystems or our geopolitical order, but to the deeper, darker forces still at play beneath the Earth's surface. It might not be an alien invasion, or a giant meteor crashing into the planet, but it could still change the course of history. And maybe that's the most unsettling part of all. It's not the sudden bang, the catastrophic eruption, or the instant crisis we're used to fearing. It's the quiet, relentless push of something we can't yet fully understand, something that has the potential to reshape the world in ways we can't even predict. And as this structure continues to grow, inch by inch, we might find ourselves not just watching an event unfold, but being part of a transformation we didn't see coming. As we pull back and reflect on everything we've discussed, it's clear that the phenomenon unfolding beneath the waters near Japan is not just a simple geological event. It's something that challenges our understanding of the Earth itself. What began as a quiet, almost unnoticed process beneath the ocean has quickly become a focal point for questions about our future, our relationship with the planet, and what it means to live on a world that is far more alive and unpredictable than we often acknowledge. To begin with, we've seen how the rise of an underwater formation, whether due to volcanic activity, tectonic shifts, or something entirely unforeseen, could send ripples through the environment in ways that stretch far beyond the ocean itself. The delicate ecosystems that have flourished in the Pacific could be drastically altered by this growing force, pushing marine life into uncharted waters. This isn't just a threat to underwater species, it's a threat to the vast global food chain that relies on the ocean for sustenance. Fishing industries around the world could be rocked by these changes, leading to shortages, conflicts, and a reevaluation of how we manage and sustain the resources we take from the sea. What might once have been considered a vast, untamable ocean could suddenly feel a lot smaller, its resources increasingly finite. We've also explored the broader environmental consequences, particularly when it comes to the way this event could affect our planet's climate. The oceans are far from a passive force. They regulate temperatures, influence global weather patterns, and play a massive role in mitigating the effects of greenhouse gases. Any significant change in the ocean's structure, whether from uplift or volcanic activity, could disturb this fragile balance. The result could be more extreme weather events, rising sea levels, or shifts in agricultural cycles that take generations to fully unfold. A seemingly subtle change beneath the surface could create a cascade of effects that reach into every corner of the Earth. And these changes, which could take decades or even centuries to fully understand, would inevitably challenge our global systems, whether they're agricultural, energy-based, or political. It's also important to consider the long-term human impact. If, as we speculated, this underwater growth is linked to a massive geological system with the potential to change the very surface of the Earth, it could bring new and unforeseen challenges for humanity. We could find ourselves grappling with altered coastlines, new islands or underwater ridges, and a reevaluation of where our resources are coming from. The rising formation could disrupt shipping lanes, alter geopolitical boundaries, and spark competition for control of new, valuable territories. The way nations approach collaboration or conflict in the future could be profoundly shaped by how we deal with this new, growing reality. As much as we've learned to live with earthquakes, tsunamis, and volcanic eruptions, this is something different, a slow-moving process that requires a more strategic, thoughtful response, even as it plays out beneath the surface. In our deeper dive into the speculative theories surrounding the cause of this underwater formation, we've ventured into the possibility of a much larger, global-scale event. What if this is the beginning of a new kind of volcanic activity? What if it's the precursor to something we've never witnessed before, something that will redefine our understanding of what's possible in our world? It's easy to imagine a sudden eruption or collapse, something dramatic and catastrophic. But what if it's the quiet growth, the subtle shifting of the planet beneath our feet, that poses the greatest challenge? The slow, steady pressure building until one day, it reaches a tipping point, and the results are far more complex than a single eruption. This brings us to the final point, the philosophical implications of such an event. We often think of disasters and geological events as singular moments in time, as catastrophic explosions or massive earthquakes. But what happens when the event is not loud or violent, but slow, almost invisible to the untrained eye? What happens when the Earth seems to shift, not in sudden tremors, but in quiet, relentless pushes that threaten to change the landscape over time? It forces us to confront our vulnerability in ways we don't often have to. It reminds us that the planet we call home is alive, constantly shifting, evolving, and sometimes growing in ways that even the best scientific minds can't predict. As humans, we tend to live with a sense of permanence, but when confronted with forces like these, forces that don't announce their presence with earthquakes or tidal waves, but simply build, silently, beneath the surface, it's a humbling experience. And perhaps, in that humbling, there's a deeper understanding. The Earth is not a fixed thing, but a living, breathing entity. It has its rhythms, its shifts, and its own mysterious patterns that we are only beginning to understand. And in that realization, we are forced to ask, are we truly prepared for the future? Are we equipped to handle the unknown, the silent forces at work beneath our feet? It's easy to live in a world where we can predict the weather, understand the science of earthquakes, or look to experts for answers. But when it comes to something as elusive and complex as this, we're left with more questions than answers. The quiet, growing force beneath the waves forces us to confront the unknown. It makes us realize how fragile our grasp on the Earth truly is. We can study, we can prepare, we can adapt, but in the end, we are still living on a planet that is constantly changing, constantly shifting beneath our feet. And so, as this mysterious formation grows slowly, quietly beneath the surface of the Pacific Ocean, we are left with the profound realization that we, too, must grow. We must adapt, not just to the world as we know it, but to the world as it could become, one that is unpredictable, full of challenges we've never faced before. We may not be able to predict the future, but we can face it with a sense of humility, curiosity, and readiness for whatever comes next. Because ultimately, the planet will keep changing, whether we're ready or not. And perhaps, in that change, there's something we can't quite see yet, something profound, something that will shape the future of humanity in ways we can only begin to imagine. If you've found this deep dive into the growing mystery beneath the ocean fascinating, don't forget to hit that like button and subscribe for more thought-provoking content. We're just scratching the surface of the incredible stories our planet has to tell. Stay tuned and join us as we explore more of the mysteries hiding beneath the waves and beyond.